Welcome to your first ever chemistry video. So in this one we're going to talk about metallurgy, which is really just working with metals. Believe it or not, a big part of metallurgy is actually chemistry, so a lot of the people who are employed by this are going to be chemists. Metallurgy is actually really broad too. It describes a lot of different things like the structural properties of metals, some forms of welding, building with metals, alloys, so getting things like stainless steel. And one of the other things that it deals with is the extraction of metals into pure forms. So believe it or not, all the copper and all the metals that are all around you every day, we don't just get those by flipping over a rock and hey look, there's a bunch of copper. Instead they have to extract them from very, very impure forms. So it starts off with mining. So if we look right here, we see them mining some what's called bauxite. And bauxite is a reddish ore. And we can see a chunk of it right there. Believe it or not, bauxite is actually where we get aluminum from. So aluminum cans, aluminum foil, even some parts in your car, all are extracted from this bauxite ore. It doesn't look much like a piece of aluminum, but if you look really closely at that rock, you can see kind of silvery specks. Those silvery specks that you see are aluminum oxide, so Al2O3. And those can then be extracted and purified to give us pure aluminum, which is where we get pop cans and other things from. The process that they have to go through to extract this is this big long thing right here. You can see they put bauxite in right there, go through a process, all the way through to where they get aluminum at the end. So it's not a very simple process. It's very long, and that's why metals tend to be more expensive. This is also a big career opportunity for a lot of people because metals, we use them a lot. And so being able to find ways to more efficiently extract these metals is always important. Now, before we go any further, I want to talk about a couple chemical terms, things that you probably learned about your freshman year but might need some refreshing on. So bauxite contains aluminum oxide, which is Al2O3. So aluminum oxide actually has two basic components. It's made of aluminum and oxygen. When we put elements like this together, we call them compounds. And it's a compound because it's composed of aluminum and oxygen. It has those subscripts, the 2 and the 3. That means a single molecule, so one unit of aluminum oxide would have 2 aluminums and 3 oxygens in it. So then the individual pieces are called elements. So a compound is composed of individual elements. So here's a couple more examples of where we get metals from. So a key word here is the word ore. So an ore is a rock that contains important minerals. So there's going to be lots of minerals mixed in there. If you think of the bauxite where we find aluminum, there's tons of other things in bauxite. It's just the aluminum that we're concerned with, so you have to have a way to extract them. And typically we deal with metals from them. So gold, silver, all of those would come from ore as well. And so if we take a look at these examples real quick, we can identify what those are. So the 3 different types of ores that we see here are hematite, which is this guy right here, that rock, and that's where we get iron from. And so if you look at this right here, hematite, Fe2O3, so iron is Fe. Really, what we're concerned with is just that little guy right there. And so Fe2O3, the hematite, is not useful to us. We have to have a way to extract just that pure iron. The next one is rutile. So rutile is where we get titanium from. Once again, this is titanium dioxide. So we need to find a way to get rid of that oxygen so we have just pure titanium that we can use for rings or parts of airplanes, things like that. And then the last one is galena. Galena is lead sulfide. This one does not have oxygen. Instead, it has sulfur in it. And once again, we need to find a way to get rid of that so we can have pure lead, and we can use it for things like fishing weights. And then the last word we're going to talk about is a lode. So a lode, you've probably heard the term mother lode. It's a deposit of ore embedded in a rock formation. So what happens is these rocks over time, like water will get in between them, then the water will freeze and it causes the rocks to crack and break. So we have these fissures in the rocks. And then over time, these ores will kind of flow inside there and get deposited. And so we're left with these formations of this right here. So this would be a lode of gold. So you can see how the rock, which is right here on either side, kind of cracked apart, probably from freezing or from an earthquake, something like that. And then heat, pressure, all that kind of stuff caused gold to form inside of there. And so we find these lodes. You can see right here, here's a lode running kind of in a river formation. And you see that there's probably some gold on the outside of this, but just the mother lode, the basic formation is right there. And so when miners find places to mine, that's what they're looking for. They're looking for those lodes that they can and extract the ore. They can take the ore to a processing plant and eventually turn it into a pure metal. So here's what mining looks like. You end up finding those lodes, so a place where there's large deposits of a particular mineral that you want, like bauxite or hematite, any of those. And you dig big holes, haul away the dirt. And so, I mean, this looks like dirt, but it's not. That's the ore. They would haul that off to the processing plant, run it through the machine, and eventually hopefully get some metal out of it. And if you look at this huge load, there's not going to be much metal inside there. That's why metals tend to be expensive. They've got to extract very, very small amounts of metal from a huge load like this. You know, a truck bed like that might only hold a pound or two at most of a particular metal. Depends on the type of metal. And then we still use these kind of mines today, but this is a lot more old-fashioned, where you'd actually go underground, find those loads, and dig them out, and then cart them back out. Alright, that's it for this video. Hopefully you got a little bit of information about where metals come from, how we get them, the science behind it, and then a couple keywords that we're going to end up using in class next time I see you guys.